The last topic that we're going to cover in this unit is convolution. So before we get into a specific definition of what convolution is, we can ask ourselves, why is convolution important? And so to really answer that question, we would need to spend a lot more time working in an area called signals and systems. And so we don't have a lot of time to go into all of that, but sort of as a quick overview, we can say in this area of signals and systems, we have this important function called our system impulse response. So important function of our system impulse response. And so typically this system impulse response is going to be denoted as h of t, lowercase h of t. And so if we think about if we sort of break down this name system impulse response, what it means is if our input to the system, x of t, is equal to our impulse function, delta t, then that's going to give us an output that equals h of t. So it's the response of our system to an impulse at the input. So over here we have our input side, and over here we have our output. And so it turns out, we're not going to go through all the analysis to show this because again, this is a fairly large area, the signals and systems, but it turns out that if our h of t is known, we can find y of t for any other input. So if h of t is known, we can find our y of t for any input x of t from this following equation, which is going to be y of t equals x of t convolved with our system impulse response h of t. So using this convolution, we can find our output for any given input. So that's a very powerful thing to be able to do. So what that means is we can either test a system or look at it theoretically for this case of having an impulse response of an impulse for our input. And once we find this h of t, we can then come back and theoretically say what our output should be for any given input. So again, a very powerful sort of tool to be able to use. So let's come back now and let's define this more clearly, this convolution. And again, we would read this as x of t convolved with h of t. So we can define this as y of t is equal to the integral from negative infinity to infinity of x of lambda times h of t minus lambda d lambda, where this lambda is just a dummy variable. And so you'll sometimes see this integral called by a couple different names. We'll see it called the convolution integral for obvious reasons. You'll also see it called the superposition integral. So our convolution integral or our superposition integral. And so what we're going to do is in the next video, we're going to look at some properties of our convolution. And then we're going to come back and we're going to simplify this integral definition a little bit. And then ultimately what we're going to do is look at how we can do this convolution graphically.